Can you hear me? Okay, you can hear me. So I want to check for the audio here because I'm using two machines in order to broadcast this session. So please, if you cannot see my screen or you cannot hear what I'm talking about, so please don't hesitate to tell me. Okay? That would be good. Okay, so I have to start with the things that I have just told you about the foundation of the game-based learning or digital educational game, right? So the first thing that I would like to mention today is about the learning theory. So actually, just
บ้านเป็นไงวันนี้ไม่มีไข้แล้วนะเอ่ออาจจะพิมพ์ผ่าตัดเขาบอกว่าจะน่าจะกลับวันเสาร์นะ
okay. I'm back. Okay, you hear me, right? So okay, today I will have to start from the definition of the game-based learning, or sometimes we can call it as a digital educational game. I use the word as the game-based learning because I want to identify the learning technique, right? This is specialized for when we use game to help us for learning, okay? And for the game, right, that we use to educate the student and using computer as a communication system or the software, right? We call digital. We use the word digital in the sense of that we use computer and we use that's why we use a digital educational game to distinguish between the normal educational game that the teacher can use some games in order to teach the student. But for our course, right, we want to design and develop the digital game that will use the computer as a machine to help us for the educational or learning. Okay, so I will first start from the word game-based learning. Actually, game-based learning is a terminology that is quite broad that leverage the engaging and interactive nature of games to enhance the educational outcomes. Right. So as it definition, so the keyword is the engagement and interaction. But this is the nature of the computer game-based learning. So combining educational contents. So in this word, right, we have to combine the educational contents with the game mechanics, right? This is fun with the education. So GBL will create what we call immersive learning experiences, right? Not just the experience about learning, but it has to be immersive that motivate learners while promoting knowledge acquisition and skill development. So this is important. So I'm going to say like this, right? When you are studying like today, right? Maybe you will feel confused. You maybe it's boring, right? So if I can catch up your attention, I can grab your attention. So and you can still with me, right? And that's we call the immersion, right? Okay, so this will help us to gain the knowledge during learning, and your skill will be improved. Okay, so when we underpinning this approach are several learning theories that I just told you that today we are going to talk about the learning theory, and yeah, that would be the important theories that you need to know in this class. So next, when we talk about the ground-based learning, right? The background of the game-based learning are many theories. So the most important two theories that I'm going to talk today will be the constructivist learning theory and experiential learning theory. These two are important because we are going to use computer in order to develop the digital educational games, right? And these two theory are the theory that's really useful for combining game and uh, knowledge contents, right? And we can also use the behavioral system and the cognitive load theory in order to enhance your uh, power of your games. It doesn't matter. And which offer this theory will offer insights into how games can foster active engagement, critical thinking, and skill application. So this theory will enhance the active engagement, critical thinking, and skill application. So this theory helps guide the design of educational games to ensure that they are both enjoyable and pedagogically effective. Pedagogy means like educational effective. Okay, so we will start from the first one. I think this one is quite is familiar with you all, right? Because it is like its name, right? It's constructivist or constructive learning theory. When we talk about the constructivism, it will emphasize the learner actively build knowledge by interact with the environment and using prior knowledge as a foundation. So the keyword of this learning theory is we have to use the prior knowledge, right? So in this figure, you can see this, right? So in order to gain the wisdom later, right? First of all, you have the basic knowledge or the existing knowledge that is the background for the learners. And then you have to add up a bit about the new knowledge. And then when we combine these two, the students or the learners combine these two knowledge, right? and then they can get the what we call derived knowledge. Okay, and at the top of this pyramid, right, we can see the wisdom, that is derived knowledge, right? When you gain something new and it is an innovation and it is a wisdom. So it could be what we call wisdom. Wisdom is the upper level of the knowledge. So game design under this theory encourage exploration. So the game must be in a type of the exploration or discovery and problem solving. So the student can gain the knowledge and the new knowledge every time they play the game. So for the constructivism, right? I want you to see this picture. Constructivism, right? Learning is constructed through the meaningful real-world experiments, experiences. Okay, so you have to start the problem solving, right? And then student culture, and then the student has to construct the knowledge, right? The student has their own perspective, and then the student can gain the knowledge from their experiences and background, combine them together, and then they have to use the active engagement or active learning during the process of learning. So this is what we call the constructivism. Once again, right, constructivism is very easy to understand. You have to start with the basic knowledge, right? And then you have to, okay, you are the designer, right? So suppose you want to the student to get the life knowledge. Maybe you have to know before that the target audience. So the target audience will be very important, and I'm going to tell you why. The target audience or the players of our game, right? So you have to define or you have to identify the target audience because you need to know the basic knowledge of them, right? If you don't know the basic knowledge of them, you cannot design the games that is suitable for them. Do you think I'm right? If you think I'm right, please type one into the chat. Okay, thank you. Thank you very much. So I will know now you still have the engagement with me, right? During my my teaching, right? And you are learning, right? So in order to how can I say, to in order to use the constructivism, right? First of all, you have to know your audience or your player first, because you need to know the basic knowledge or the prior knowledge of the learners or the user. And then you have to know the new knowledge that you are going to give them. And then after you give them the knowledge, right? So you will expect that the student will get the knowledge, the new knowledge, or what we call derived knowledge. Okay, I'm going to give you the examples in a GFIG. Okay, no problem. So the most important part for the constructivism is target audience identification. Okay, and the next one is the prior knowledge. Right, you have to know the background of the learners. So there are more important things that you have to keep in your mind during the process of designing the game. So no problem, I'm going to tell you later on. So in the meantime, you can just know about the constructivism is like the staircases. Okay, you have to start from the bottom, but in order to get the higher knowledge or the more difficult knowledge, you have to start from the lowest staircase, and then you have to top up by the new knowledge. Does that make sense? Okay, so I will give you some examples of how to use the constructivism or constructive learning theory. In Minecraft education edition, right? This game enables students to explore the concept like geometry, ecosystems and history through open-ended problem-solving tasks. Okay, for this example, if you want to teach the chemistry, right, have to start from the chemistry element table, right? Starting from the easiest one, that is if you could remember, I'm not sure which elements laws will be taught first. Helium, neon, argon, krypton, xenon, radon. Am right? Or this one, hydrogen, lithium, sodium, potassium, rubidium, cesium, right? You have to start from the easiest one, right? So, and then you have to start from the basic background of the elements table using the basic one, and then you can add up. If you want to teach more, maybe about oxygen or carbon, nitrogen, right? Maybe you need to pass these two. Which one is scoop 1? This is scoop 8, right? This is scoop 1. I'm not sure. Anyone in this room can help me? Am I right? Okay, this is a good example of constructivism, where the learner has to construct their understanding by solving challenges, and such as, for example, designing sustainable cities or recreating historical landmark. So this is the what we call the Minecraft for the history, for teaching the history. Okay, are you happy? Okay, so I would like to introduce you to psychologists. I'm not sure. This is the two persons who are I can say the fathers of the constructivist or constructive learning theory. This is a Piaget and Vygotsky, right? Constructivist theory emphasize the learner to construct the knowledge through the active engagement. So not just only starting from the basic knowledge, right? And then add up the new knowledge, and then you can get the derived knowledge. Derived knowledge. Not only, but also they have to have the active engagement to the system with the environment, and building on prior knowledge and experiences. So the learners or the students can build on top of the prior knowledge or their background experiences. So this is, if you are design based on these kinds of these things, right? We can call that your idea, your design is you use the constructivist learning theory. Okay. So the key principle, so we can come up with the key principle of the constructive learning theory. The learning is active. It has to be active. And it is a learner-centered, right? This is active. That is not, that is opposite of the passive learning, right? That the teacher will teach in front of the classroom, and that we call it as it is a teacher-centric or teacher-centered. Okay, and the constructivism emphasize this what we call scaffolding. What does it mean by scaffolding? Let's think about the building, right? Before, when you are trying to build the second floor, the third floor, and the fourth floor of the building, you need to have the bamboo, right, to make it to be the scaffolding, or we can call it the hint, right, or the help for the user. or the learners until they can perform independently. We can just remove the scaffolding out of the system. So this is we call the scaffolding. This one is quite important, especially for the constructivist scaffolding. And the knowledge is constructed through interaction. So that's why game or digital educational game is important. It's a good idea because the learners or the students can interact with the system, with the environment that is a game. Okay, and the last one is focus on the process of learning, not just the outcome. Okay. Okay, up to now, do you have any question about constructivism? Okay, it needs to be the active learning, user-centric scaffolding, interaction with the environment, and focus on process of learning. So these are the keywords that you have to keep in your mind during designing the constructive learning, during the DEG or digital educational game. So when you get these key principles, we can go to what we call the example, right? So this is an example of a coding game, right? We want to create a game to teach coding, where the player solve puzzle by writing and testing code to progress. This is an example. This is the name of the project that suppose we are going to do. And you have to set up the strengths of this. This game will encourage deep understanding, critical thinking, and skill transfer. Okay, this is you have to identify the strength. And the challenge of this game is it requires careful design to ensure progression and support without overwhelming players. Okay, this is a list of the game that you have to design with the constructivist principle. Okay, and this game will emphasize on exploration, problem solving, and self-guide discovery. So today in class assignment today, I'm going to set up or ask you to develop the DEG, right, using the constructivism, and then you have to try to set up the. I'm going to give you some example. The example, right? So before we will go to the DEG design, right? I myself believe that if you start from CAI, that would be very helpful for you to transfer the idea of the you can get the idea of the CAI and can be used it for the DEG. So I suggest you to start from CI. You have to design the CI, right? Using the constructivist principles. This is the group of two people, right? And yeah, you have to do two things, right? Um, to design the CI and design the DEG based on the constructivism learning theory. Okay, so okay, in order to go into detail, maybe you are now still okay. I also have the additional materials for you, right? About the details of this chapter that I'm teaching you now about okay, game-based learning. Okay, this is more details about what I have just introduce you in my PowerPoint. And okay, these are the key theories of the game-based learning using constructivist learning theory. Okay, and I provide you both in English and in Thai, because I was using this material for the undergrad student as well, in order to teach them know about the details of these two learning theories. Okay, and then you can go through this also. Okay, so before I will ask you to do the assignment or in class exercise, I would like to show my example. Okay, so this is my example. Okay, let me. Suppose I'm going to design the CI or the game for teaching number-based conversion. Okay, you have known before that base conversion is important in computer science or in computer engineering, because we are not going to deal with the computer using the base 10, right? We will control the computer using base 2 number. So what you have to know as a basic background for computer, you have to start from the base 2 and base 10 conversion. So we have to start from the learning objectives. The goal of this AI is to enable, you have to set up this objective. The goal of this AI is to enable students to understand and apply the number-based conversion principle. Okay, and this one we are going to focus on the constructivism learning theory. Okay, this is the objective. And you have to define the specific objectives, right? In this case, right, you have to understand the concept of different number bases, right? Like base 2 or base 10. And then the students can perform conversion between the number bases. So you need to know, you need to design how to teach them to convert between number bases. And then you have to apply number-based conversion in problem-solving scenario. And the last one is to develop proficiency in identifying patterns and relationship across bases. So these are the specific objectives that you need the learners to understand your number base. Okay, first of all, you have to start from the learning objectives. Second, you need to convert the learning objectives into learning outcomes. When we talk about the learning objective, right, it is in the sense of the objective is about the teacher, in the teacher point of view, right? Teacher want to teach what, or expect the student to understand what. This is objectives, but the outcomes are different. The outcomes will be like the capability or competence of the student after study your information or your knowledge content. So if you want to specify the learning outcome, like you have to write down, like by the end of the CI program, student will be able to first describe the characteristic and usage of different number bases. 2, accurately convert numbers between many bases. 3, solve real-world problems involving number-based conversion. And the last one is the mastery level, that is demonstrate mastery in advanced topics like direct conversion between non-decimal bases. So this is if you are good enough in conversion, so you can go to the mastery level. Okay, you can see that there are 4 items. So from the learning outcome, you can map into 4 levels as well. Okay, for each level, you will have the level 1 basics number bases, 2 convert involving base 10, 3 direct base to base conversion. Okay, this is a higher level from the level 2, and then 4, the fourth level, application and advanced problem in the real world scenario that can challenge you. So this is the CI, right? So in CI, you can have the level. As I use the word level, maybe you can use the word lesson 1, lesson 2, lesson 3, lesson 4. That's okay, right? But in this class, maybe I use the level, okay, in order to indicate that the student will have the level progression. Level progression will reflect to the more knowledge gained. Okay, so this will be the list of the levels that you have to teach the student in CI, right? And the last one will be the sometimes you arrange the objective and it's mapped into the assessment method examples, right? So from this, right, from learning outcome, right? Learning outcome. So you need to map to assessment. From assessment, you can map to the teaching and learning. Yeah, and this one you have to use the constructivist approach in order to sort the level 1, level 2, level 3, and level 4, right? In this example, it's quite, I'm lucky that the level is directly mapped from the outcome, right, one by one, and in the sorting order. Okay, so you can come up with the topic, right? So this one, the topic arranged by difficulty, it starting from the level 1, right? Level 1 basic number basis. So this will be the list of the things that is okay, when we call this as a topic, right? And these 3 we can call it as subtopics from this level, and so on, right? So now you can order your topics, right, into 4 levels, and for each level you can have subtopic. That's also you have to sort it in the difficulty, from the difficulty orders, by using the constructivist approach. Okay, so if you can come up with this, right, so we can guarantee that your design is based on the constructivist approach. Up to this, do you get the point? Do you think, is it sound to do this? I'm going to digest what I have, or the Kierke and Vygotsky theory, right? And if suppose I want to design a CI, right, what I have to do is I have to specify the learning objective, right? From learning objective, I have to specify the learning outcome. From learning outcomes, I have to show the assessments. And from assessment, I can know the teaching and learning, or the knowledge. Okay, the knowledge. I have to know, in order to teach them, I have to know the topics or the knowledge that I'm going to teach first. So this is the 4th item, that is the topic and the subtopics that you need to make it in the sorting order, in the ascending order. Okay, so this is the conclusion for the for the CI program in order to use the for the base conversion, and it has to guarantee this program, this CI program design ensures a gradual for learning number-based conversion. And by integrating interactive lesson assessment and real-world application, students can build a strong foundation and confidently tackle advanced problems in mathematics and computer science. So we here we come. And then you have to come up with the fourth item here. The topic arranged by difficulty approach. Okay, so when you get the CI, right, like this, right? So I think it's a bit more easy that you can do or set up the digital educational game design for teaching number-based conversion. You can borrow the same idea of specify the learning outcomes, right? You can copy this learning outcome, right? Starting from learning outcome, and then you have to set the game idea of and story of your game. For this example, we can set up the title to be the binary quest, the Questbreaker Chronicles. So, and maybe we can just have the story, right? The player take the role of a rookie code breaker recruited by the Intergalactic Code Authority, or ICA. Right? The ICA is tasked with deciphering encrypted messages from different planets that use unique number systems, blah, 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 blah. And the player's mission is to learn and master number-based conversions to unlock secrets, decode message, and save the galaxy from a looming cyber threat. Okay, we start the story. So when you read this story, you feel like immersion or immersive, right? The story can make you feel like you are into this game, right? The part of this game, the part of, you can feel like you are the part of, you have to write the story, right? So storytelling is also an important class that I'm going to teach you as well. Okay, but in the meantime, maybe you can give the game idea, just lovely idea of the game. And then, okay, from the game, right, here we comes to the level design. That is why I used in CI, I use the level because I want to map that level in CI into the level design here in the game, in your game. Right? Level 1, basic number bases. Level 2, converting involving base 10. 3, direct base to base. Okay, so you may not understand about this, right? So for this, right, convert from base 2 to 10, and teaching converts base 10 to 2, something like this. And we also have the base or hexadecimal base 16 to 10 or base 10 to 16. So you need to use the base 10 as the intermediate basis. Okay, and from this, right, this can be the ground knowledge for the level 3. That is, if you want to direct convert from base 2 to base 16 or base 16 to base 2. So you can also use what we call, like, you have to convert from, okay, maybe from base 2 to base 10, and then base 10 back to base. Okay, maybe that is not the, if you want to convert from base 2 to base 16, right, you can use the conversion from base 2 to base 10, and then from base 10, base 2 to base 10, and then base 10 to base 16. So this is what we call the transitive closure, right, in computer science, right? If you in this, right, you have convert base 2 to base 10, convert base 2 to base 10, And then you have the convex base 10 to base 16, base 10 to base 16. So you can derive the concept of direct base to base or base 2 to base 16 conversion. Do you get my point? If you think you get my point, please help me type 5 in the chat box so I will know you still follow me. So this is why we call the scaffolding. Can you see it, right? So starting from the conversion involving base 10, right? You can have these 4 conversions functions, right? And then if you want to have the direct base to base conversion, you can just simply use this to the first conversion and use this to the second conversion. And then you can have the direct 2 to base 16 conversion. So this is what we call constructivism. Constructivism. Very clear, right? Okay, and the last one, level 4. Maybe you have to, okay, to make it, to apply this conversion in the real world scenario or the advanced scenario is up to you, right? So you can use the in the gameplay, you can use the player must infiltrate the enemy cyber vault by solving complex conversion puzzles involving large numbers and mixed bases. Okay, so this is the most advanced level of this game, right? And the challenge is multi-step conversion and pattern recognition under the time pressure. So in this level, maybe you need to use the time in order to play the game. You have to make it fast to solve the problem within the limited time. And then the goal is to unlock the final vault and save the galaxy. So this will be the goal of the game, right? So I'm going to teach you about the game, right? And one important things that you need to know is the game need the goal, compelling goal. When I teach you about the game design, right? I will teach you the definition of the game, right? And the definition of the game is you have to solve or you have to achieve the what we call compelling goal. When you play game, you need to specify the goal. If you don't have the goal, we will not call it the game. Do you understand my point? So that's why this word is important. Unlock. This one is important. You need to put into your design. Go, unlock the final vault and save the galaxy. Okay, and then you can add up more detail about your storytelling for each level in order to make it to be immersion, to be immersive. Immersive means ดื่มด่ำ เนอะ in Thai ดื่มด่ำ in English it is immersive, right? You can feel like you are in a part of the game, you are in a part of the hero in this game, right? You have to feel like that, and then that's we call immersion. So this is the game, and from immersion, engage, the word engagement will be accomplished. Okay, and this is accessing player through the game assessment, right? You can borrow the idea of assessment from CI, but CI more or less the assessment is direct, but in game, right, it is not that direct. It could be the indirect game, indirect assessment. You cannot use the pre-test or post-test in order to assess or evaluate the knowledge of the student or the learners or the players, the game players, but you need to Okay, you need the assessment method, for example, progress metrics. Sometimes progress can be an assessment, a good assessment. Progress from level 1 to level 2, at least it is guaranteed that you know about the definition of the basis, right? The base, number based system. And the feedback system also a good assessment method. Achievement awards, a level of success, final mission report. So in your game, right, you need to provide the assessment indirectly. Sometimes we can call intrinsic, right? Intrinsic assessment. Okay. Okay. This is constructivist. Are you tired? I feel like this is only the design for the constructivist learning theorem. Okay, so now I would like you to do the in-class activities. Now it is 15 minutes. 15 minutes now. So I will give you a short break for 10 minutes, and then we will come back. And please provide me. Do you want to select your partner by yourself, or you want me to select your partner? I mean your group mate. So I want you to set up a group of 2. Okay. And then after the break, right, you have to select one topic. I think you are almost from the computer science or computer engineering or IT, right? So you know about array, right? I will give you the topic array, or you can select linked list. Okay, this Okay, so shall we have a short break for 10 minutes and then we come back and then try to do the in-class activity for maybe for 30 minutes. Okay. Okay, so we will could you I have already set up the breakout room, no? So please go to your this desired breakout room with your group mate, right? And then try to do the in-class exercise starting from CI, right? Um, I would like I would like you to select one of my topic, array or linked list. Okay, maybe linked list is a bit harder, but I think it is challenging. Okay, so please go to breakout room and then I will go to talk to you individually. Can you hear me?